Welcome to this third video of week 2, in which I will continue from the first and second lesson of this week. In the first video, you have learned about industrial ecology, life cycle assessment and system thinking at the end of this figure. And in the second video, life cycle assessment has been explained in more detail. In this third lesson, you will see how the technical innovation that has been presented in the first week connects to the environmental impacts and other societal issues that has been talked about so far in the second week. To show you the integral approach of the energy transition, you will first hear more about the Sustainable Development Goals. You might be familiar with these 17 colored blocks already. If not, please check them out at the website of the United Nations. And the so-called Sustainable Development Goals, or for short the SDGs, have been launched in 2015 by the United Nations with the ambition to be achieved by 2030. The 17 SDGs rank from rather daily issues, as the availability of clean water, number 6, or responsible consumption and production, number 12, all the way to overly complex issues like no poverty, number 1, or zero hunger, number 2, or peace, justice and strong institutions, number 16. One way to categorize these 17 goals is by placing them on the 4 system levels that have been presented before. In this way, it becomes truly clear that the Sustainable Development Goals need changes on all 4 system levels. We need new types of products and production. We need innovative designs of supply chains, value chains, and we need innovative organizations and new business models. And we need further development and rethinking of our institutions. Let's go back to the SDGs again, and let's have a look on how they relate to the energy transition. Most clearly related are the climate action, number 13, and the affordable and clean energy, number 7. As you have seen before, also industry, innovation and infrastructure, number 9, and sustainable cities and communities, number 11, have a strong connection to the energy transition. Because these goals are highly influenced by the types of industries and cities that we like to work in and to live in. Both the industry and the power sector decide how clean the air will be and how sustainable the transition to an alternative energy future is. The industry also decides about responsible consumption and production, number 12, by the choice of alternative heating systems and renewable energy supply. One important lesson that we also can take from this is that energy transition and circular economy are strongly related. And that will be explained in the next slide. And how these various goals and themes are related is also part of the Partnerships for the Goals, that is number 17. In this number 17 of the SDGs, we'll come back later in this video when we talk about governance and the emission trading schemes. I already mentioned circular economy, and that is schematized here in the so-called butterfly diagram by the Ellen MacArthur Foundation. In this week, we do not have the time to explain the concept in much detail, so if you want to learn more, please visit the website of the Ellen MacArthur Foundation for detailed documentation. For now, it is sufficient to keep in mind that we face, next to the energy transition, a major challenge in terms of resource transition. Resources become scarce, both for energy supply as well to produce alternative energy technologies. And this scarcity can be partially overcome by the implementation of a circular economy instead of a linear economy. And it is clear from the scheme that the circular economy extends the availability of materials. However, a circular economy will require more energy to enable all the feedback loops. And this creates an interesting dilemma. The energy transition should not create extensive scarcity, and the circular economy should not consume all sustainable energy to compensate for that same scarcity. In 2019, Anna Coat, Master of Science student in our Industrial Ecology program, did an interesting design research into the production of electricity cables. Electrification of the industry and the decentralized production of energy by wind and sun requires a peak in the production of several types of cables. At one hand, the increased production contributes to the energy transition. And on the other hand, the cables must be produced according to the design principles of a circular economy, otherwise the loss of metals and other scarce materials will be irreversible. And therefore the energy transition and circular economy meet each other at the socio-technical level, level 3, and in level 4 of the Sustainable Development System change figure that we presented before. In Europe, the integral way to govern energy systems, carbon emissions, climate change is the European Union Trading System, the EU ETS. The system is in the 4th phase now, that is planned to run from 2021 till 2030, and the first phase dates from 2005. At that time, the EU ETS was the first emission trading system in the world. An EU ETS works with a cap and trade system, meaning that companies can trade their emission allowance when they expect to be under the maximum allowed amount of greenhouse gases, the cap, and they can trade then with other companies that might exceed their maximum amount. This trading scheme results in a market price for carbon dioxide, CO2, and that has been between 10 to 20 euro per ton for CO2 for quite some time. At this moment it is about 75 euros per ton CO2, and it shows high fluctuations. Some modeling studies have now estimated the carbon price to be about 100 to 130 euros per ton CO2 in 2030. Integrated energy systems require political action, as you have seen. It also requires action from industrial sectors. In their tracking report of 2021 in November, the International Energy Agency has presented 4 actions for the pulp and paper industry, the case study that has been discussed in earlier videos as well. In these 4 recommended actions, you can see again how energy transition and circular economy go hand in hand. The first action is to accelerate energy efficiency and recycling, which illustrates this going together even more. You have also seen in week 1 how alternative energy and heating systems can look like, which are reflected upon in the second recommendation. And then the third action links to the EU ETS that I just have presented and to number 17 of the SDGs about partnerships. And the last point shows that an integrated energy system needs proper modeling and data collection to show that what the sustainable potential is. Thank you for your attention.